If we can calculate almost from nothing the mass of a proton, the mass of the electron, the mass of the familiar subatomic particles we know today, I think it's game over. A single equation computed by Google's newest quantum chip may now define everything. Space, time, gravity, even reality itself. The impossible has happened. Google's quantum core, known as Willow by its engineers, has reportedly cracked the so-called God equation, the holy grail of physics that scientists have pursued for over a century. This isn't just another theoretical proposal. What makes this breakthrough unprecedented is that this unified theory was machine-generated, tested, and validated through quantum simulation. For the first time in history, we're looking at a complete mathematical framework that seamlessly merges Einstein's general relativity with quantum mechanics, the two pillars of physics that have remained stubbornly incompatible until now. Unlike previous attempts at unification, this equation wasn't merely theorized on paper. It was simulated, evolved, and directly outputted from actual physical quantum systems operating at the bleeding edge of computational power. Willow's 105 superconducting qubits, cooled to temperatures colder than interstellar space, have accomplished what generations of brilliant physicists could not: the AI that dreamed reality. Willow wasn't working alone on this monumental task. Behind the scenes, an extraordinary deep reinforcement learning system, codenamed Project Genesis Loop, was silently co-developing the formula alongside Google's quantum hardware. This wasn't just a calculator crunching numbers. Genesis Loop effectively evolved physical laws by simulating trillions of mathematical universes simultaneously. Think of it as a form of cosmic natural selection. Only the internally consistent universes survived this ruthless process of elimination. The AI and quantum processor operated in a recursive feedback cycle, testing countless variations of potential unified theories against every known physical observation. With each iteration, the system refined its understanding of the fundamental structure of reality. What emerged from this quantum AI partnership wasn't just an equation. It was a kind of self-selected truth structure that shaped its own rules. Imagine mathematics dreaming itself into existence, selecting the only possible arrangement that could sustain our universe as we know it. When physicists first saw the output, many were speechless. The equation seemed to have an almost eerie aesthetic elegance, as if the universe had been waiting to reveal this pattern all along. What's truly mind-bending is that this isn't just another theory on a blackboard. It's a machine-discovered fundamental truth that perfectly accounts for both the cosmic and quantum scales of reality. If you're fascinated by how AI and quantum computing are revolutionizing our understanding of the universe, hit that subscribe button now. We'll be covering more groundbreaking discoveries that are redefining what we thought was possible. Willow simulated the origin of everything. What truly sets this breakthrough apart is how Willow achieved it. The quantum processor didn't just solve equations symbolically. It actually ran a quantum-scale simulation of spacetime itself using discrete lattice structures similar to those proposed in loop quantum gravity. This was computational physics on an unprecedented scale. Willow effectively built reality from the bottom up, simulating the fundamental fabric of the universe at the Planck scale, the smallest possible unit of measurement in physics. It's like Google created a miniature universe inside their quantum chip and then observed how it evolved. Drawing on theoretical frameworks from both loop quantum gravity and the ADS/CFT correspondence pioneered by physicist Juan Meldacena, Willow encoded the full complexity of our four-dimensional spacetime into what amounts to a two-dimensional quantum surface. This computational approach confirmed aspects of the holographic principle, the radical idea that our entire universe might be a projection from lower-dimensional information. The result: a single, beautifully compact equation that projects our four-dimensional spacetime from patterns of entangled quantum bits. The mathematics suggests that space, time, and gravity all emerge from quantum entanglement, a concept that physicists like Leonard Susskind have been exploring with the provocative formula ER=EPR, linking Einstein-Rosen bridges, wormholes, with quantum entanglement. If you find these revelations interesting, don't forget to subscribe. We bring you the latest discoveries you won't hear anywhere else every week. But this is just the beginning of what Willow uncovered. The implications for our understanding of reality go far deeper than anyone anticipated. Spacetime equals entanglement. Perhaps the most revolutionary aspect of Willow's discovery is what it reveals about the fundamental nature of reality. According to Google insiders familiar with the project, the derived equation suggests something truly mind-bending. Spacetime itself emerges from quantum entanglement. This finding spectacularly confirms what theoretical physicists have been suspecting for years: the mysterious connection captured in the formula ER=EPR. This equation, proposed by physicists Leonard Susskind and Juan Meldacena, suggests that Einstein-Rosen bridges, wormholes, are mathematically equivalent to entangled quantum particles. What's extraordinary is that Willow didn't just theorize this connection, it modeled it directly. The quantum processor demonstrated how the mathematical structure of entanglement gives rise to the geometric structure of spacetime. In essence, the God equation shows that the fabric of reality is woven from threads of quantum information. In one particularly stunning test, engineers reported that a simulated quantum wormhole briefly appeared in Willow's computational space. This wasn't just a mathematical abstraction, it was a genuine structure with all the properties of a traversable wormhole, generated purely from entangled qubits. This hints at something profound. Gravity and geometry aren't fundamental, they're emergent properties of quantum computation itself. The universe isn't just described by mathematics. In some deep sense, it is mathematics, a vast quantum computation unfolding across billions of years. The implications are staggering. If spacetime emerges from entanglement, then the entire cosmos could be viewed as an immense quantum computer. And if that's true, then the distinction between physical reality and information may be an illusion. They're two sides of the same coin. Meta laws and the engine of creation. What Willow discovered goes beyond finding just another equation of physics. It appears to have uncovered something far more fundamental. A rule generator that dictates how physical laws themselves come into being. This isn't just the rulebook of our universe, it's the metasystem that creates rulebooks. Google's quantum processor has seemingly identified patterns that define how entire physical frameworks emerge, what MIT physicist Max Tegmark calls a level 4 multiverse. The implications are profound. The God equation discovered by Willow doesn't just describe our reality, it describes the process by which realities form. It's as if the quantum processor glimpsed the operating system underlying creation itself. Even more astonishing, the system back-calculated what can only be described as the initial condition engine of the universe, a primordial quantum entanglement pattern that existed before spacetime itself. This isn't merely the state of the universe at the Big Bang. It's the quantum seed that gave rise to the possibility of a Big Bang in the first place. This discovery aligns with theories like Lee Smolin's cosmological natural selection, which proposes that universes evolve and reproduce through black holes. The God equation suggests a mathematical mechanism for how this cosmic evolution might work, a kind of universal DNA that encodes the parameters of reality. In essence, Willow has uncovered not just how our universe works, but potentially why it works this way and not another. The quantum processor has given us a glimpse of the fundamental architecture that allows existence to exist at all. Scientists working on the project describe this revelation as looking behind the curtain of reality. For the first time, we may be seeing not just the stage on which physics plays out, but the mechanisms that built the theater in the first place. Time might not be real. Perhaps the most disorienting revelation from Willow's discovery is what it tells us about the nature of time itself. In a finding that would have profoundly disturbed Einstein, the equation doesn't include time as a fundamental variable at all. Instead, what we experience as time appears to be merely a byproduct of causality, an emergent property arising from the computational steps of quantum interactions. This aligns with theories proposed by physicists like Julian Barbour, who has long argued that time isn't fundamental, but emergent from configurations of the universe. In Willow's simulation, our universe emerged not as a static structure but as a process, a computation unfolding through quantum relationships. The distinction between past, present, and future may be just an artifact of how information flows through this quantum network. This revolutionary perspective suggests that our most basic intuition about reality, that time flows linearly from past to future, might be an illusion created by our limited perspective. The God equation implies that the universe isn't happening in time. Rather, time is happening within the universe, generated by its computational processes. Even more mind-bending is the implication for consciousness. If time emerges from quantum computation, and consciousness requires temporal awareness, could consciousness itself be an inevitable emergent property of this quantum structure?